Welcome to VINDAL'S Academy, and wow, it has been a very long night for me because it's approximately 1:08 a.m. in the morning, and I need to do this. I want to cheat them. I want us to cheat them, okay? And remember, it's 2024 Waec Physics Practical for number one. So don't you ever go to the hall to stress yourself. If you truly understand what I'm going to do today, you have water and you have kerosene in that number one, don't suffer yourself. And you are going to see how you're going to blast it. And that is serious. Please, I want to say very thank you for those of you that are subscribing and that have been very civil and encouraging me. You are the reason why I am saying this up early. Do this. Let's go. All right. From the apparatus given, of course, this is the best. You have to keep it very simple. This is the best we have. A rotor stand, a spiral spring, the mass, the beaker, the water, and then we are asked to use 50, 100, 150, 200 grams to be able to do this experiment. And if you look at the experiment, it's boiling down to relative density. Our relative density has different formulas, but for the sake of the apparatus given to us, I am detecting, and just like every other physics teachers, saying that it's going to be upthrust in a liquid over upthrust in water. But remember, this formula is a formula for upthrust. And remember that there is a question that will come under it, which you also need to solve. However, if I have this, first of all, let me talk about how the graph is going to be likely. If you are given this to solve, you now have that. And our question said that we are going to plot a graph. Plot a graph of V against U. So for that reason, let me tell you or predict the kind of graph you're going to have, so that when you see your own, you also know how you're going to have it. Because most students struggle in the exam to say they don't know if the graph is curved, if it's straight line, if the graph is cutting through the horizontal axis or through the vertical axis. Well, look at this. If I make V the subject formula, I'm going to have V I'm going to have that V is equal to relative density times U. Now, it simply means that if I also bring a straight line equation graph, I did that in the first part. I did this also there, how to cheat physics practical. I'm going to have that Y is equal to mx plus c. For this reason, remember y is always on the vertical and x is always on the horizontal. Then what is this m? This m is the coefficient of what you are plotting on the horizontal. Coefficient of whatever you are plotting on the horizontal is the slope of the graph. Now, this C is wherever the graph cuts. The graph may cut like this, we call this place C. If the graph cuts like this, we call this place C. If the graph cuts through the origin, we call the origin C. But since this particular equation, this is our attention right now. In this case, since V is the vertical, since V is the subject formula, it means V will be plotted on the vertical according to this equation or according to that instruction. And then U is going to be plotted on the horizontal according to this. So what is the coefficient of what is on the horizontal? It's relative density. That means our slope is going to be relative density. Now, but where will our graph cut? Since there is nothing here, so it's going to be plus 0. Therefore, our graph is going to go through this one, pass through the origin. Or sometimes mistakes can occur because human beings are full of errors. It may not be able to pass exactly at that zero, or you need to maintain that. You need to maintain a very high accuracy in order to plot your graph the way it should be. For that reason, let's go ahead. Let me clean this part. All right, I have told you how the graph is going to look like. How can I complete this table without doing the experiment? I want you to know something. It is proven, you can also Google it, that this equation is this, whatever we are doing here is to find the relative density of that liquid kerosene. That is it. But kerosene has been known that relative density of kerosene is 0.8. So in place of this place, I'm going to say 0.8. Something is sure. So we have found this. So I'm going to keep this. The next thing should be, how do I find my U, my V, or how do I find my U? One thing I want you to know is this. You see, this mass in air can never go out of this 50. So I'm going to convert it, but it's going to be in Newton. So whenever you want to convert from grams to Newton, divide by 100. So this divided by 100 is going to give you 0.5. This divided by 100 is going to give you 1.00. Sorry, let me complete that. Two decimal places. Divide this by 100, you have 1.50. Divide it by 100, you have 2.00. So that is basically what is going to, because this is the gram, but when you measure it in air, you know you hang the mass in air without putting it inside any liquid. You're going to have this same value should be the same, unless some cases whereby your mass may have a little difference in what it was written on the body. Now, under this part, this is the weight when in mass in water. So if you're looking at this video right now, this video at this point, you see that when you put the mass inside water, the water fell out. There are some water that was displaced. That displacement of the water is as a result of upthrust, or what we call buoyancy. So that upthrust is what is pushing down water. Now, we have for water and for kerosene. You must know that the upthrust in water is more than the upthrust in kerosene. Therefore, if I put 50 grams inside water, it can never be 50. It should be somewhere around 46 or 45 or 44 or 47. So I'm going to choose 45. So if I had put this 50 grams inside, I'm going to have 45. If I divide 45 by 100, so that I'll convert it to Newton, I'm going to have 0.45. Good. So I've gotten this. So what should I do? I will now get this. To get this, I'm going to say 0.5 minus, because W1 minus W2 is going to be this. So I'm going to have 50 minus 45 is 5, it's going to be 0.05. The next thing you should do is go back here right now to this formula. In place of this U, put 0.05 and find the value of V. So use your calculator, 0.8 times 0.05. That V is, you write 0.04. And then what else do? You now use this second equation to find the value of this. In place of V, I'm putting 0.04, which is equal to W1 is already known as 0.5 minus W3 is what I'm looking for. So that simply means that 0.5 minus 0.04. So this W is coming this way. I have W3 is equal to 0.5 minus 0.04. You are going to have 0.45 0.46. All right, you see, I have filled this value. To find out if what we are doing is correct, just say V divided by this. Will you still have 0.8? Because relative density must be 0.8. So I'm going to do that for the second one under this 100. So remember, I will still go with this first formula, which is 0. So this is U. Okay, still 0. So what I will do is, I will call this place 90, 0.9. Now, 100 minus 0.9 is going to give me 0.1. So I'm going to write So I'm going to have 0.10 here because I'm calling this one 0.90. So 0.90, because I'm suspecting that if I put 100 grams inside water, I'm going to have 90 because of the upthrust. So at this point, and this is my U, so if I put 0.1 here, 0.08, and that is my V. So I'll go here and write 0.08. Now, to get this part, I'll say that V is equal to W1 minus W3. So this V is something like 0.08, which is equal to weight in air is 1 minus weight when immersed in water. So at this point, I'm going to say that 1 minus, it's just like saying 100 minus 8. 100 minus 8 is going to be 92. So we have that W sub 3 is equal to 0.92. So W3 is going to be 0.92. Now, if you check very well, like I said from the beginning, these values must be less than this value. That's the way they're going. So let's do finally the last one here. The last one I'm going to do is to, when you come to 150, if you immerse 150 in water, it can never give you 150. It will give you around, let me choose a lower number. So under 150, let me say 120. So this is going to be 1.20. As I have 1.20 here, 50 minus 20 is going to be 30. Yes, this value must increase. So this is 0.30. You see they are increasing. I must maintain those considerations. So I'm going to say 0.8 is equal to V all over under U is 0.3. V is going to be 0.8 times 3, 24, 0.24. Go here and write 0.24. Now, when I have 0.24, I will now find this. How do I find this? How do I get this value? So I'm going to say that V is equal to weight in air minus weight in kerosene. V, I already know V as 0.24, which is equal to weight in kerosene. Weight in air is 1.5. 1.5 minus weight in kerosene. So weight in kerosene is going to be 1.5. Right? So under this 1.26, I'll write 1.26 here. So ladies and gentlemen, this is my table of value. Now, how am I going to confirm if whatever I've done is correct? I will say this divided by this. Will I have 0.8? Yes, that one will confirm. This divided by this, I had 0.8. Let me say this divided by this if I have 0.8. Of course, 24 divided by 3 is 0.28. So you say 0.24 divided by 0.3. It's still 0.8. So that's that. If you go to your graph, which I'm going to do maybe by a few days now, before the practical day, you have V plot against you. You are going to have a straight line graph which will pass through the region. Ladies and gentlemen, this is where I draw the curtain for this edition. Please, I want to beg you, don't forget to hit the subscribe button, like this video, subscribe, and tell me how good this lesson is. Have a nice day, and return again.